When it comes to some of our favorite disaster tropes, we normally fall back on the classics, like asteroids, or Yellowstone erupting, or even something more exotic, like a rogue black hole wandering through our solar system. These may be fun to hypothesize about, but the odds are significantly smaller than a little solar attention in the form of a massive coronal mass ejection, or CME. A direct hit from a CME would create a catastrophe for our modern technological world that would effectively change the course of modern human history, and not in a good way. Might also cause a delay in when the next video comes out, just saying. The best place for us to start is, of course, with, well, the sun. Our sun is a G-type main sequence star that is often referred to as a yellow dwarf. And not like one of the dwarfs with Snow White. Fun fact, if you look at the optical spectrum of our sun, it is much closer to white than yellow. The yellow color we observe on Earth is due to a scattering effect in our atmosphere. Back to our sun, it is mostly composed of hydrogen that is held together by gravity, and the force of that gravity causes the hydrogen to undergo nuclear fusion, where the hydrogen at the core of the sun is fused together to form helium. Of course, if you wouldn't burn up there, your voice would sound very funny. In fact, the sun makes about 600 million tons of helium every second. One of the byproducts of fusion is energy, and that is so powerful we can feel it from here. And luckily so, as life would not exist without it. So, the hydrogen in the sun is not stationary, and the gas in the form of burning plasma is in constant motion, and that movement creates a magnetic field around the sun. It is that magnetic field that causes sunspots and solar flares. A sunspot is a concentration of magnetic flux within the sun's magnetic field, and this area will appear darker than the rest of the sun, thus creating a visible spot on the sun. Larger sunspots can actually be seen from Earth with a telescope. Of course, don't stare directly at the sun if you hope to see tomorrow. Sunspots are an indication of intense magnetic activity, and it is in these regions that solar flares and coronal mass ejections are more likely to appear. The magnetic activity in these regions can push through the photosphere, that's that very outer edge of the sun, and cause the outer corona, just moving in a little bit further, and the sun to link to the solar interior. This tangled magnetic field can then snap back into place, which causes a release of considerable amount of energy in the form of a solar flare. Sometimes the flare may be accompanied by a coronal mass ejection, or if you remember CME from earlier. That CME will release plasma and magnetic field into the sun's solar wind. At the top of the video, I spoke of a big disaster involving one of these CMEs. If a strong enough CME were to hit the Earth, the effects on our modern technology would be horrific. To be clear, the CME would not destroy the Earth or us, but the charged particles that come with it would be catastrophic for electronic equipment. The Earth has its own magnetic field, and that CME would get caught up in it, which is a good thing for us. But most CMEs are not too strong, and thus our magnetic shield has no problems dispersing the charges from the CME. When a CME gets a little bit stronger, there can be issues with the charge reaching some of our satellites and either disrupting communication or outright damaging the satellites. Tell ya, Elon Musk is having a bad day when this happens. These do happen every once in a while, and we deal with the damage just fine. However, a monster CME is what we are worried about. A significantly strong CME will create a lot of charge, and it will still get caught in the Earth's magnetic field, and it will still damage those satellites. But in this case, the charge is strong enough, it's able to mirror the charge on the surface of the Earth. In most cases, this mirror charge will simply go to ground. This is good. However, in places with power lines and electronics, instead of going to ground, the charge will go into the wires and transformers, which are not designed to handle that amount of energy. That's a lot of voltage. The result is that it will blow the transformers as well as the generators, and it can even damage a lot of electronic equipment as well. For this nightmare scenario, it is the transformers and generators that concern us most. If a transformer blows, we simply replace the transformer, and that is pretty simple. However, when all of our transformers blow, we have a huge problem. For one, we do not have enough to replace them. And that means we will need a large-scale ramp-up on transformer manufacturing. Okay, sounds good, right? But maybe not, as transformers typically can take 6 months to a year to make. The reason for that is even though a basic transformer is fairly simple, a bigger one used in cities is much more complex, as it needs to be designed to handle all sorts of different input and output voltages. And we are not talking about small numbers, folks. So, what does this all mean? This means, in our worst case scenario, a good amount of the population will be without power for up to a year or even longer. Let that sink in. If you live in a northern latitude, we're talking about going through winter without power. People are simply not ready for a prolonged power outage of that nature. Unfortunately, a lot of people will not make it through such an event. Without electricity or communications, help will simply not be there, and people will need to rely on themselves. It will not be a pretty picture, to say the least. So, what are the odds of this actually happening? Well, maybe a little higher than you're thinking. It has already happened in 1859. We call it the Carrington Event, after Richard Carrington, who sketched the sunspots where the CMA originated from. The event caused a lot of damage to telegraph wires and even caught some poles on fire. The aurora from the geomagnetic storm stretched as far south as Cuba, and it was bright enough at night that people could read newspapers by the light of the aurora. Needless to say, we were lucky that it was only telegraphs. It's already happened. We are good then. Nope. It will happen again. The sun goes through an 11-year solar cycle, and during the solar maximum part of that cycle, we get increased magnetic activity. CMEs happen all the time, more so in a solar maximum. Superstorms on average have a 4% chance of occurring each year, and one as strong as the Carrington event has a 0.7% chance per year. That seems like a lot, but you also have to factor in if the superstorm CMA is pointed at us. Luckily, the last time that was the case was 1859. There have been some close calls. It will happen again. That is a certainty, and that is something we need to decide as a society how we will deal with it, or if we will even be ready when our number comes up. This is a disaster that is mostly preventable. We do have the technology to harden our electric grids against such a geostorm. Unfortunately, governments do not want to spend the money it would take to do so. Hopefully, this could change in the future, but for now we have option B. A CME does not just show up, as it moves slower than light. Thus, we have a warning that it is coming. Hopefully, if we are given a 20-hour window or more, we can look at taking transformers off the grid and protecting as much of the grid as we possibly can. There will still be damage, but maybe we can recover much faster. As our observations of the sun improve, that warning may be longer, and we may have more time to prepare for the next Carrington event. If you love science content, then please subscribe to the channel for a weekly science video. Until next time, stay curious.